So we're going to do the second day of notes of our implicit differentiation. Really the big difference here is going to be just finding the second derivative of some type of implicit represented relation or function or whatever this is. So what we're going to do here is, to find the second derivative, is we're going to just find the first derivative first, have it all nice and organized, and then we'll find the second derivative from there. So to go ahead and do that, we're going to find the derivative of 4x squared, which is just going to be 8x, minus derivative of 2y squared with respect to x is going to be 4y, and then we're going to tag it dy dx, equals, a lot of people get mixed up here, but this should be a big old 0 because there's no variable there on that side with 9. And just now we're going to solve for dy dx. So we're going to get negative 4y dy dx equals, you're going to subtract the 8x over. So when we divide this negative 4y, we're going to get dy over dx equals negative 8x over negative 4y, which is the same thing as 2x over y. Okay? So we're good so far. So that's the first derivative. Let's go ahead and take the second derivative. So take the second derivative. You're going to do the derivative of dy dx. It's d squared y. So it's the second derivative of y with respect to x twice. That's why it's d squared y over dx squared equals, I'm focusing on this guy right here. This is going to be quotient rule. Okay? So it's going to be the top one is first. So we're going to get 2 times the bottom minus the top. Derivative of the bottom is just going to be dy dx all over the bottom squared. Okay? So this is going to give me 2y. Just cleaning up the notation here. Didn't really do much in this step. Y squared. Now, we don't want to have this in our answer right here, this derivative, because it is represented already. dy over dx is the same thing as, and I have it right here, as 2x over y. So when I do that, I'm going to get equals 2y minus 2x times 2x over y all over y squared. Not done yet. I'm going to clean this up. So I'm going to get 2y minus 4x squared all over y, and then that's all over y squared. Okay? So now what I'm going to do is I want to make this into one fraction up here so I can get rid of this little fraction. Okay? So I'm going to multiply this by y over y. So y over y. So I can make this into one fraction. So this is going to become 2y squared minus 4x squared all over y. And then that's all over y squared. So if we flip the second here and multiply, we're actually going to get this is going to become y to the third on the bottom. So 2y squared minus 4x squared all over y cubed. So what I'm doing here is I'm flipping this, multiplying it here. That's why I'm going to get y cubed on the bottom. Now, a lot of times for these multiple choice questions with second derivatives of implicit, this would not be actually be an answer choice. They like to do a substitution from the original. So look for a sub. So this occurs very often on second derivatives using implicit. So look for a substitution. So hey, this is almost the same thing, but the signs are changed. So it's fair to say that this right here is equal to a negative 9. Because if we make everything negative, this would work out. So our final answer here is going to be negative 9 over y cubed. And that's our final second derivative. Okay? So a lot of math going on there, not calculus necessarily related math. I'm just trying to organize stuff, lots of algebra work. So big focus there. All right, next question. is going to be differentiating with respect to t. V equals 1/3 pi r squared h. Now, does this look familiar, by the way? V stands for volume, r is going to stand for radius, h is going to stand for height. This is actually going to be the volume of a cone. Okay, so we're going to differentiate it with respect to t. Now, I don't see any t's here, so they're all going to be represented kind of like how it was dy dx. This will be dv, not dx, but dt, dr dt, dh dt. And that's how they're all going to be represented here. So let's go ahead and do that. So the derivative of v with respect to t is going to be dv dt equals. This is a constant, so I'm going to keep the 1/3 pi out in front. But right here, r squared h, those are two different variables. That's going to produce a product rule because it's an r times an h. Okay, so I'm going to just put up big old parentheses here because I'm going to do this product rule. So the derivative of the first, so a derivative of r squared is 2r. And we need to tag it dr dt times h, okay, plus, keep the first, because this is product rule. Derivative of the second is just going to be dh dt. And that's really all that I can do here with simplifying, distributing there is not going to really do much for me. So there's nothing to clean up there. So this is just going to be this answer. And this is kind of help us get ready for some upcoming lessons with related rates. So just another healthy look at that using implicit differentiation. And that is it for day 2 of implicit differentiation.